Newton Raphson method. So we will evaluate the cube root of 12, means take x is equal to cube root of 12. So cubing both sides, we will get x cube is equal to 12, or you can say x cube minus 12 is equal to, we will take it as fx. So this will be our equation which we will solve using Newton Raphson method. So we will start it with by taking initial guess. Say any value, we can say take as 2 as initial guess. So we will find the value. In iteration 1 we will take x0 is equal to 2, and the formula for calculating the next value x1 is x0 minus fx over f dash x0. So we will calculate first of all f of x0, that is f of 2, which will be 2 cube minus 12, that is 8 minus 12, that is equal to minus 4, and f dash of x0. So to calculate f dash, we are given that fx is equal to x cube minus 12. So f dash of x is derivative of this function, which is 3x square. Derivative of constant is always 0, so 3x square minus 0, which is equal to 3 of x square, 3 into x square. So whenever we calculate f dash of x0, means f dash of 2, which will be equal to 3 into 2 the square, that is 3 into 4, that will be equal to 12. So we will calculate both these values in each and every iteration, that is fx and f dash x. So by using the formula, this formula, we will calculate x1 is equal to 2 minus 4 divided by 12, and if you calculate it, it will come out to be 3.5. So we have x1 is equal to 3.5. So we will take this value for next iteration as x0. x0 is equal to 3.5 for next iteration. So let's go to next iteration. So now take x0 is equal to 3.5. So again calculate f of x0, that is f of 3.5, by substituting it in the equation, that is 3.5 the cube minus 12, which will be equal to 30.875, and again f dash of x0, that is f dash of 3.5, which will be equal to 3 into 3.5 the square, which will be 36.75. and now we calculate the value of x1 by using this formula. So this will be 3.5 minus 30.875 divided by 36.75, which will be equal to 2.65 and 99. So this is the value of x1, 2.6599, and for next iteration we will take it as x0, means we will take x0 as 2.6599 for next iteration. So in iteration third, take x0 is equal to 2.6599, and x1, for calculating x1 you have to calculate f of x0, that is f of 2.6599, which will be 6.818, 6.818, and f dash of x0, that is f dash of 2.6599, which will be equal to 21.225. So the value of x1 will be 2.6599 minus 6.818 divided by 21.225. If you solve it, you will get it as 2.3387. So for next iteration, this value will become x0, 2.3387. Now move to next iteration. Iteration 4. Take x0 is equal to 2.3387 and calculate f of x0, that is f of 2.3387, which will be 0.7913, and f dash of x0, which is f dash of 2.3387, and which will be equal to 16.4086. Put these values in this equation and you will get value of x1, which is 2.3387 minus f dash fx over f dash x, which is minus 0.7913 over 16.4086, and if you solve it, you will get 2.2905 as the value of x1. So 2.2905. So this value will become x0 in the next iteration. So we will go to next iteration, that is 5, and here we will take x0 is equal to 2.2905 and calculate value of fx0, that is f of 2.2905, which will be equal to 0.0166, and we will also calculate f dash of x0, that is f dash of 2.2905, which will be 15.7392, and by using this formula we will get the value of x1 is equal to 2.2905 minus 0.0166 divided by 15.7392, and if you calculate it, you will get 2.2894. So it means you got x1 as 2.2894, and this value will become x0 in the next iteration. Let's move to the next iteration, that is 6. Take x0 is equal to 2.2894. Again calculate f of x0, that is f of 2.2894, which will comes out to be minus 0.000005, and f dash of x0, that is f dash of 2.2894, which will be 15.7241 and calculate value of x1 by using this formula. We will get x1 is equal to 2.2894 minus 0.0005 over 15.7241, so which comes out to be 2.289,404. So if you see in the previous iteration we got 2.2894 and in this iteration we also got 2.2894. x1 is equal to 2.289404. If you can see if we see the answer up to 4 digits, so it is same as in previous iteration. So we will stop here as we have got our answer. It's correct up to 4 decimal places. If you want to correct up to 5 or 6 decimal places, then you have to do more iterations, but it's enough for up to 4 decimal points. So solution is x is equal to 2.2894.